Hi everybody. Today we are going on to inequalities. Last year, technically, we finished up equations, and this year we're starting with inequalities, which really are just like equations, but instead of using an equal sign, we'll have these inequality symbols. So just to label them and know which is which, this one is a less than or equal to. That would make this one greater than or equal to. This one, although it's not used very often, it means not equal to. And then this would be less than and greater than. So then next it says the solutions of an inequality are all of the values the variable can be to make the inequality true. These values are called the solution set. So with the equations, we solved and got to an answer like x equals 4. That was the solution. Now we'll solve and get to an answer like x is greater than 3. So that could be a lot of numbers. There's a lot of numbers that could be greater than 3. That's why we call it a solution set. It's the entire set of numbers that x can be. So here x could be, I'm going to write this in word form too. X is greater than, so it could be 4, 5, 6, 7, 8, and so on. X could also be 3.1, 3.2. It just can't be 3. It has to be more than just 3 on its own. So as I mentioned, to solve inequalities, we solve them just like we would solve equations. So for example, if we have x plus 3 is greater than 4, we draw the line now. Why aren't you working? All right, doesn't want to draw a line there. But we draw a line down where the equal sign was. Now it's just a greater than sign. And to get rid of this plus 3 from x, I would subtract 3 on both sides. That gets rid of the plus 3. You still don't want to work? Oh, there we go. So then we're left with just x over here. Now we have a greater than sign still. And 4 minus 3 is 1. So the solution set is x is greater than 1. X can be any number greater than 1. So an extra thing that comes with inequalities that didn't come with solving equations is graphing them. And there's two things that we consider when we graph. We need to consider what circle we'll put on the graph, so whether it be an open circle or a closed circle, and what direction the arrow would be, whether it's going to point to the left or to the right. I don't know if that was the right direction for you guys, but anyways. So a closed circle will be when we're dealing with the equal to sign, so less than or equal to and greater than or equal to. It's a closed circle because it's going to include that value. If x is greater than or equal to 1, it could be 1, so you want to put a closed circle on 1, and then the arrow in the correct direction. It's an open circle if it doesn't include those equal to, if it's just less than or greater than. And then the arrow is going to point in the direction of either the greater numbers or the less numbers. These are both greater thans. This one is the greater than or equal to, but regardless, the greater numbers are to the right on a number line. These are both less than signs, and the lesser numbers are both to the left on the number line. So you can kind of see here each of the graphs. If x is greater than 3, you'd have an open circle because it's just greater than 3. It doesn't include 3. And since it's greater than 3, we draw an arrow to the right. Here, x is less than 3. Again, it's just a less than 3. It doesn't include 3, so it's an open circle, but now it's going to the left because that's where all of the numbers are that are less than 3. And then these are both greater than or equal to. and less than or equal to, so the only change is that the open circle becomes filled because x could include 3 as well. X could equal 3 or be greater than it. So, given this example, if I want to graph x is greater than -5, well, -5 is right here. If x is greater than it, that means it can't be -5, it just has to be greater than it. So I would put an open circle on -5. I like to just draw it up top so I can see it better, but you can draw it right on the -5 if you want. So an open circle, because it's just greater than, it's not greater than or equal to. And then, since it's greater than, these are all of the numbers that are greater than -5, so the arrow would point to that direction since it's pointing to those numbers. Also a nice little trick, the greater than symbol kind of looks like an arrow pointing to this direction, and that can kind of always tell you how you know which direction your arrow is going to go. Okay, so then we're going to go through a couple of examples on the back of solving and graphing inequalities. Maybe, yep, okay, here we go. So like I said, solve them just like we solved equations. Draw our line down the symbol and do what we need to do to get x by itself. Right now x is being multiplied by 3. So to undo that, I would divide both sides by 3. The times 3 and dividing by 3 cancel out, leaving me with just x. And again, now instead of an equal sign, it's still a less than sign. And -9 divided by 3 is -3. All right, so then let's graph it over here. We want to find -3 since that's part of the solution set. Since x is just less than it, we want to put an open circle so it's not less than or equal to, it's just less than. And then this would be the less than direction. Okay, this kind of looks like an arrow pointing to the left, and less than is going to the left. These are the numbers less than -3. All right, going on to the next one. We have x minus 0.2 is greater than 1.8. So to get rid of this minus 0.2, I want to add 0.2 on both sides. The minus and the plus 0.2 cancel out, leaving me with just x. The greater than symbol, 1.8 plus 0.2 is just 2. So x is greater than 2 is our answer. So we'll find 2. Because it's just greater than, it's not equal to 2. Put an open circle. And again, since x is greater than 2, these are the numbers greater than 2 to the right of that number on the number line. All right, next we have a two-step inequality, just like our two-step equations. It's going to take more than one thing to get x by itself, but that's okay. We want to start by getting rid of that -5 by adding 5 on both sides. The minus and the plus 5 cancel out, leaving me with just 2x. Again, greater than or equal to is the symbol. -1 plus 5 is 4. And then lastly, x is being multiplied by 2. So to undo that, we want to divide both sides by 2. So we're left with x is greater than or equal to 2. So again, we're at 2, but now since it's greater than or equal to 2, we're going to put a closed circle. Because x could also equal 2, we want to put a closed circle showing that we're including that number of 2. And again, greater than or equal to, greater than, these are the numbers greater than, to the right. All right, our last inequality example is one in factored form. So just like equations in factored form, you can solve it either way. You could distribute this 4, and if that's how you like it and that's how you want to do it that way, and see if you get the same answer that I get when I do it the other way. Because I'm going to use the other method where I get rid of this times 4 by dividing both sides by 4. I think this was the unpopular method, so I just wanted to, I don't know, go the path less traveled. So this times 4 and divided by 4 cancel out, leaving me with just x minus 1 is less than or equal to negative 8 divided by 4 is negative 2. And then we just have to get rid of that minus 1 by adding 1 on both sides. That leaves me with x is less than or equal to negative 2 plus 1 is negative 1. So x is less than or equal to negative 1 should be your answer no matter which method you chose. Negative 1 is right here. Since it's less than or equal to, it could be negative 1, so we want to put a closed circle on it. And then less than is in that direction. So the arrow would be going to the left. And that's all I got. All right, so time for you to practice on your own. Go Browns, and talk to you soon.